Welcome back guys in our 16th class with Rapid Spanning Tree Protocol RSTP. RSTP is an extended technology of spanning tree protocol, and for those who doesn't know much about spanning tree protocol, we have already made a class on spanning tree protocol, that is class 15. Kindly refer to the class 15 and understand much about spanning tree protocol. So let's dig much into rapid spanning tree protocol. What is rapid spanning tree protocol? All these information I have taken them from Cisco study website, right? Alright, so let's go on. Rapid spanning tree protocol was introduced to replace spanning tree protocol, right? And it has a standard of IEEE 802.1q, okay, while spanning tree protocol has a standard of 802.1d, okay, that's the difference, right? So spanning tree protocol and rapid spanning tree protocols are similar in some ways but are different in some ways too, right? So let's see the differences between spanning tree protocol and rapid spanning tree protocol. Good. RSTP enables fast convergence time than STP. STP port states, listening, blocking and disables are merged into a single state, but in RSTP it's in the discarding state, right? So STP features two ports type we discussed earlier, a root and designated port, but while in RSTP it adds two additional port types, which is alternate and backup port, right? With STP, the root switch generates and sends hello to all other switches, right? While in RSTP, each switch generates its own hellos frames, okay, right? So let's understand this diagram. Remember, the concept of spanning tree protocol and rapid spanning tree protocol is to prevent loops in the network, okay? So in order to avoid loops, RSTP has placed one port on switch 3 in alternate state, okay? So this port is in alternate state, right? This port will not process or forward any frames except RSTP messages, okay? Then, however, if the root port on S3 fails, whenever this fails, okay, the alternate port will rapidly become the root port. That's what we have discussed earlier, okay? Whenever this one fails, the convergence time, this one will become the root port very faster, right? Okay, right. So let's see what we have next. How RSTP works. Just like spanning tree protocol, rapid spanning tree protocol creates a topology database of the network, right? Then to prevent loops, some interfaces on switches are placed in forwarding state while others in discarding state, right? So how does RSTP decide in which state the port will be placed? We need to consider certain criteria. So here are the criteria. All switches in a network elect a root switch, just like in STP. Then all working interface on the root switch are placed in the forwarding state. The same thing in spanning tree protocol. Then all other switch called non-root switches determine the best path to get to the root switch. The same as STP. The port used to reach the root switch is called root port and is placed in forwarding state. The same concept, guys. So remember these points. Then on the shared Ethernet segments, The switch with the best path to reach the root switch is placed in a forwarding state. Same concept. That switch is called designated switch and its port is called designated port. Very simple, guys. The same concept that we discussed earlier in STP, spanning tree protocol. So all other interfaces are placed in discarding state and will not forward frames, right? So let's discuss the diagram above. Okay, it comprises of 3 switches and redundant links. So let's say switch 1 is selected as the root switch. Switch 1 is our root switch. Okay, all ports in switch 1 is placed in forwarding state, right? So S2 and S3 choose ports with the lowest cost to reach the root switch. We discussed this one in our spanning tree protocol. The same concept. Then these ports are placed in forwarding state. The root ports are placed in forwarding state. Then on the shared Ethernet segments between S2 and S3, see, port FA0/1 on S2 as the lowest cost to reach root switch. This port is now placed in forwarding state. And to prevent loops, port FA0/1 on S3 is placed in discarding state, right? Then if the port on S3 fails, the alternate port which will quickly take over and become the root port. What do you mean by that one? Whenever this one fails, this alternate port will pick up as the root port. Guys, it's the same concept that we learned in spanning tree protocol. So it's just like a recap, right? Let's see what we have next. RSTP ports and status. Just the same as in spanning tree protocol. The same concept. So ports in RSTP, we have a root port. The port with the lowest path, the port with the lowest cost path to forward packets to the root bridge, right? Then designated port, the interface through which the bridge is connected to the LAN, which provides the lowest path, cost path from the LAN to the root bridge. The same, we have discussed this, guys. It's very simple. Then in RSTP there are some additional ports like alternate port and backup ports. So what is alternate ports? Provides an alternate path to the root bridge from the root port. Okay, then backup port provides a backup path to the designated port path towards spanning tree leaves. Okay, this provides a configuration in which 2 ports are connected in a loop by point-to-point link. Backup ports are also used. Backup ports are also used when a LAN has 2 or more established connection to the shared segment, right? Then the last port in RSTP, disable. A disabled port in RSTP means that port is not participating in spanning tree, right? Okay, so let's understand the status of ports in RSTP, right? A disabled status. A port is in disabled status when it's not participating in STP, right? Right. Blocking status. Blocking state. A port is in blocking state when it cannot forward traffic or landmark addresses. Guys, in exams, this is the mostly asked questions, states in STP or RSTP is the same thing. Ports in a blocking state cannot forward traffic or LAN MAC addresses. Then the port in listening state. The port in listening state cannot forward traffic and also cannot LAN MAC addresses. Right? So let's go to learning state. A port in learning state cannot forward traffic, but it can LAN MAC addresses. Remember guys, blocking and listening state, those ports cannot forward traffic or LAN MAC addresses. And now in the learning state, the port cannot forward traffic, but it can LAN new MAC addresses, right? So the forwarding state. In the forwarding state, the port can forward traffic and LAN new MAC addresses. So guys, RSTP is very simple because we have already discussed everything in our spanning tree protocol. So guys, let's understand how to configure RSTP. We use this command: spanning tree mode rapid PV ST. So let's do this in our packet tracer. So guys, I have already drawn a diagram comprising of 3 switches, just like what we have been using to discuss the spanning tree protocol. So we have switch 0, switch 1 and switch 2. Which switch is our root switch? And which ports are in forwarding state and are in blocking state? This is our root switch. And we said all ports in the root switch are in forwarding state, meaning now this one is in forwarding state and this one is in forwarding state. The 2 switches are non-root switches, right? And we said a non-root switch uses a root port to reach to the root switch. So this one is a root port in a non-root switch because it uses it to reach the root switch. It is in forwarding state. To know which port is in forwarding state or a link, we just check. Here is green and here is orange. So orange is in blocking state, green is in forwarding state, right? So guys, the 2 switches are non-root switches, and we said non-root switch uses root ports to reach to the root switch. So this one is a root port, this one is a root port, right? Okay, so let's configure RSTP. Let's start with this switch. Enable. Before we do that, let's check the status of spanning tree protocol in that switch. We just write show spanning tree like that and hit enter. Okay guys, check. The spanning tree protocol is always enabled by default, right? Is spanning tree protocol enabled? You use protocol this one, right? Priority is given there, MAC address of the switch is given there. Then there's a very important information here. The bridge is the root, right? Okay, that switch is the root switch. And let's go to the interface. We said all the interface of a root switch are in forwarding state. See, status forwarding, right? Okay, so let's configure spanning tree protocol. Then I have already copied that command. I'll just paste it. That's a command to configure spanning tree protocol. That's a command to configure rapid spanning tree protocol, and hit enter. Redo, right, exit. And now let's check the status of spanning tree protocol in the switch. Which command did we use? Show spanning tree. Okay guys, see, now the protocol has changed to RSTP. Initially it was IEEE, okay, but now it has changed to RSTP because we have configured the switch to be in rapid spanning tree protocol.